Okay, so for this video, we're going to talk about graphing an ellipse. Excuse me. As you can see, I've got actually almost the formula written down. I forgot that the bottoms are squared there, but and I guess I also forgot, sorry, these are also squared. Forgot my squares, but that's what the formula is going to look like for an ellipse. Now, if you notice, it kind of resembles a circle formula a little bit. It's got x minus h and y minus k, which are also in the circle formula. And it's important to remember that h and k are always attached to the x and the y, but the h is always attached to the x and the k is always attached to the y. So a couple things we need to do here when we graph our ellipse. The center is always, just like the circle, it's always hk. So for this question right here, we've got positive 2 and positive 5. Remember, since these are minuses here, that means that, our center is actually in this problem going to be negative 2, negative 5, because they would be the opposites. So I can put that on my, there's the center. Okay, and the next thing I'm going to do is I'm going to have to plot my vertices. And that just means I'm going to find basically where these points are located. And the way to do that is I'm going to look under the x, and I see that that's 25, which is really 5 squared. I've got to break these down into their squares to actually see what I'm going to do. But basically, this means that for the x, in the x direction, my vertices or my end, it's an ellipse is kind of like an oval. So when I say like the end points, I mean like the top and bottom or the sides. That's what I'm looking at right now for my vertices. But in the x direction, we're going to move 5. So you look at the bottom of the fraction to figure out how much you're moving. So I'm going to move 5 left, and I'm going to move 5 right, since this is the x direction. So 5 left would be 1, 2, 3, 4, 5. I'll place a point right there. Oh, and actually, I put my center in the wrong spot. Hold on a second. That's sorry about that. You guys probably caught that. It's negative 2, negative 5. So it'd be down here. Negative 2, negative 5 would be right there. Now we can fill it out, though. We're going to move in the 5 in the left direction. 1, 2, 3, 4, 5. We're going to move 5 in the right direction, which would be 1, 2, 3, 4, 5 right there. And then we're going to do the same thing with the y's, but we're going to look under the y to figure out what we're doing there, which would be 3. So I'm going to go up 3. I'm going to go down 3. And this, I mean, I'm going to do my best to draw the ellipse here, because it should look like an oval and not a diamond. And obviously I'm doing it on a computer, which is tough. But yeah, that should look more like an oval. So that's how you graph that. That's not too bad. So graph this ellipse. Well, we can't graph this ellipse until we have, like our formula says, a 1. It equal to 1. So to do that, we can divide everything by 9. And I'm going to do that, all of those separately. So I'll have x squared divided by 9. I'll have plus, oh, sorry about that. I'll have, well, 9 divided by 9, those would cancel out. So we'll have just the y left over. So we'll have y squared divided by 9, or sorry, not divided by 9, they're canceled out. And then we'll have equal to 1. Okay, so let's look at what we have here. And I'm going to make this into something that resembles a little bit more like this. X squared is, you might have already seen this from the circles, but this is going to be x minus 0 squared, if we wanted to write it all out, plus y minus 0 squared. And then on the bottom of this one, we had a 9, which I'm actually going to rewrite as 3 squared. And then over here, we don't really have anything under there, so we can put a 1 under, and I'm just going to put that as 1 squared, because 1 squared technically is 1. So, and then this would all be equal to 1 since we divided those 9s. Okay, so that's what we're going to do. We had to change the form first, and some of those are going to be easier than others. This one might be one of the easier ones, but you have to change the form, and then we can plot it. I can see that my h and k are at 0, 0 for this problem, so I'm going to put it right in the center. That would be any time that you have just like the X or the Y by themselves up there. And then in the X direction, I can move 3 to the left and right, 3 and 3. And then for this one, I'm going to move 1 in the Y direction. And that should be it for my ellipse. Let's move on to this last one, graph the ellipse. Now it looks a little bit different. This is one where we're going to actually have to do some completing the square to solve. So I got a lot of room on the right-hand side. I'm going to use it. First, I'm going to move the x's next to each other. So like that, plus y squared minus 6y. And then I'm going to move that negative 23 over to the other side. So it'll be a positive 23 if I move it over. Now I can pull something out of the x's, so I'll pull out a 4. That'll leave me with x squared minus 2x. I'm going to leave myself some room because I'm completing the square. And then I'm going to go plus, I can't take anything out of this y squared, so I'll just leave it as y squared minus 6y, leave some space, equals 23. Okay, so now I'm going to complete the square, so that means I'll put a plus 1 in there, and I'll put a plus 9 in there. And then I got to think about what I actually added to the left-hand side of the equation. It looks to me like I added 4 in the first part and then 9 in the second part, so that means I've added 13. So that means I have to add 13 to this side as well. Okay, let's see. So now we can factor. So 4, this would be x plus, nope, that would be x minus 1 squared plus y minus 3 squared equals 36. And now I can, let's see, I'm going to divide both sides by 36 because if you remember our original equation, we need it to be equal to 1 here. And so the only way we can do that is by dividing everything by 36. If I divide this by 36, divide this by 36, and divide this by 36, luckily that's a 4, so this should work out pretty well for us. So 4 over 36 simplifies to like 1 over 9. So we'll have x minus 1 over 9, this was squared, plus y minus 3 squared over 36, and this is equal to 1. Then we can graph our ellipse just like we were doing before. So let's see here. For my center, that would be at 1, 3. So 1, 3 would be right there. And then in the x direction, that's like 3 squared. So I'll go 3, 1, 2, 3, and 1, 2, 3. And then in the y direction, that's like 6 squared. So I'm going to go up 6, 1, 2, 3, 4, 5, 6. And I'm going to go down 6, 1, 2, 3, 4, 5, 6. And again, I'm not doing the best job of drawing. This is tough on a computer, but that would be approximately my ellipse. Okay, and I think we're going to call it there for this video.